In the previous video, I provided a rationale why I am gaining interest in using R, while at the same time, I was a bit anxious and fidgety when I learned that we're going to use this particular platform in our statistics class here at Tech. I also mentioned that I am making this videos as a personal diary, perhaps, on my progress in using this relatively new platform, and also to help future students and some of my colleagues who are interested in trying out and making use of this platform for their research studies. I also mentioned that in the previous video that and my belief, the learning curve is quite steep when it comes to using this platform. But when we are able to get hold of the basic and fundamental principles on how this particular machine works, it might be a little easy to run simple analysis that we might need in our research. I also provided an introduction on what uh, the R Studio window looks like and what are the things that you can make use in this window. So for in this video, what I'm going to do is we're going to run a simple regression analysis, but my purpose in doing this uh, video really is to focus on the descriptive part, the part wherein we import the data, we try to run descriptive statistics, and also probably make or create some box plots and scatter plots, which might be helpful when we do our exploratory data analysis, even before we go to the actual regression analysis. The data set that I'll be using in this video is the same data set that we're using in our statistics class. It is from the book of Timothy Keith, Multiple Regression and Beyond, an Introduction to Multiple Regression and Structural Equation Modeling. I find this book easy to understand, and I think for someone like me who is starting multiple regression and structural equation modeling using a different platform, it helps me practice a lot because it has a lot of practice data sets. And although much of the examples in the book were done using SPSS, it is interesting and delightful to be able to replicate the results that they have on the book using R. So if you're interested to use these data sets as well and run and replicate what they have done, it is a nice investment if you buy this book. So just like what I mentioned earlier, the first thing that we would want to do in analyzing the data set is first to be able to import the data set that we're going to use into R. And commonly, what I observe in myself and my other classmates who are also new in R is that most of us are uh, doing our data preparation using the specific statistical software that we were accustomed to. For instance, in my case, since my comfort zone is SPSS, so several of the data sets that I am working on my personal research are uploaded or imported on SPSS. That is I do my data preparation there. I deal with missing values using SPSS, and once everything is ready, then I upload it to R. But I also know that as you get more advanced in your use of R, you can actually make use of R to do all those data preparation procedures. So importing data set in R is relatively easy because you can use this point and click function that you can see on the RStudio uh, under the environment tab. So when you click the environment tab, it will bring you to this uh, window wherein you see import data set. So when you click import data set, you will be having several options there. It will ask you, are you importing text or CSV file? Are you importing Excel, SPSS, SAS, data, documents into R? And basically just make sure that you're clicking on the right options that aligns with the data set that you have. So in my case, I usually use the reader option because this is what I use to import CSV files. I also use Excel and SPSS because these are the data formats that I usually have when I prepare the data for class or for my own research. Uh, in in this example, we're going to use the CSV file from Keith's book. So I will click the reader option, and it will bring me to this window, which has a browse button here and some other import options that you have, and the code preview. This is the preview of the code if you want to use the syntax on the R console. So if I'm going to use the point and click function, I can just click on browse and it will bring us to the regular finder that you have on your laptop. So I'm using a MacBook Air. So I am brought to this finder here. All of my data that I work with is stored in the class exercises folder in my laptop, where I have subfolders labeled data for all the data sets that I have to work on, documents for other documents such as art history, which I'll be showing probably in later videos, the output that I have, and the scripts that I use to run all those analyses. So I want to open a data, a CSV file. So I'll just click on that file, click open, and what will happen is that it will show you a preview of what the data looks like. So as you can see, it's retrieving a preview data that you can work on. So this is how my data set looks like. So it has uh, column labels, and it has all the values that I need. So I think at this particular point, what is there are two important things that I think is necessary, at least in my experience. First is that uh, the first row as names option, which means that if I click on this one, if I tick on this one, it tells R that the first row in your CSV file are value labels. If you don't click on this one, it will treat the first row as part of the data. So and it will screw your analysis. So if your CSV file has a value label, then I would make sure to click on this particular box. Another thing here that has caused some form of trouble in our experience is the missing data option, which is the NA option here. So as you probably are aware of, when you work on your data in another software, there are several conventions on how we label missing data. In our case, in our laboratory, when we use SPSS, the convention is to make use of some crazy numbers, such as negative 9999 or positive 99999 to label missing data. And I think it's also uh, if you read on the statistics book of Andy Field, it's also one of his recommendations so that you can easily track on uh, if your uh, analysis is quite cranky. But in R, the convention is that you have to label missing data as NA. So if you're importing a CSV file, or other files for that matter, I and the missing values are empty in that file that you're importing, it is always good to click on NA, and that will tell R that all the empty spaces in that particular file, which are missing values, should be labeled as NA. So if I do that, and when I'm ready to import it, I just need to click on the import button at the lower right. So if I import that, my data set will be viewed in the source box here on the top. So you can see now that the CSV file with the file name and underscore 1000 underscore stud underscore and so on is shown here with the respective uh, variable labels and the values with those missing values indicated or labeled as NA. So that's one of the uh, process on how to import your data set. And once your data set is imported, then you can proceed with all the other analysis that you want to do. Uh, but there are other ways on how you can import data sets. And in my case, uh, it would since I'm using CSV, Excel, and SPSS, so I need to install specific packages to be able to import these data sets here. So if you are importing CSV file, then basically the library or the package that you need is the reader package, which is part of the, I think this is part of the base R, which allows you to read rectangular text data. So if you are not sure what reader, and what package the reader library belongs to, then we can just probably check it by using question mark reader and check to see. And here in the help column, it would show that it's really the readr package is there to read rectangular text data, including CSV, TSV, and FWF files. Another library that I find useful here when I'm working on with Excel file is the read Excel library. So this particular library, I'm going to use this if I am importing Excel file. And the Haven library. So the Haven library that you are seeing here is specifically to import and export SPSS data or SES file. I'm also using the foreign package to read data stored by other statistical softwares, mostly SPSS. So there are many different options on how you can import data set in R. So in this particular example, I can I can either make use of the read R package to read my CSV file. So, or I can make use of the foreign package to read the SPSS files. Um, so if I run this particular command, uh, it will be able to import my data set on using a particular uh, function relative to the type of data that I am using. Okay, so that's one of the things about importing data. Okay, But before importing the data, I think another thing that has to be considered is that you should be able to call in the library first, because as I mentioned earlier, there are very specific libraries that are used to import specific kinds of data. Right. So another thing that I usually do, this is something that I don't know, I did not know when I was really starting or a month ago, is that I needed to set the working directory for my analyses. And when we say working directory, this is basically telling R that the files that you need and uh, are stored in a particular folder, and that all files that you will save later on should also be stored in the specific working directory that you identified. So this one you can actually do using point and click approach. So if I am going to set my working directory using the point and click approach, I just need to go to the files button here, proceed to the uh, folder that I want to indicate as my working directory, which in my case is class exercises. So I go to I will go to the folder that I want to, which is class exercises. Then here, you can see the more option with the gear. So if I click that one, it will give me several choices. So and what is important in setting the working directory is this particular option, set as working directory. So if I click that, then uh, it sets class exercises folder as my working directory. Another way to do that is basically to make use of the setwd function, which also appears here in the console when you do the point and click approach. So I can just type in setwd, then open parenthesis, then identify the path name of the folder, uh, then close parenthesis, and run it in R. Okay. So I'll clear up the environments and the history so that we have a fresh start. So if we do these two things in order, so what I usually do is uh, I have made the scripts already typed in a script file. In this case, I'm using the chapter 4.r script. I type in the title of the chapter or of the task that I'm supposed to do. So in R, the hashtag or the pound sign has a specific function, and that is to you can use it to comment out specific text. In M plus, commenting commenting out is done by using the exclamation point, and in SPSS, it is done by using the asterisk sign. So when we say we comment things out, it means that you're indicating that this text is not that it will not be read as a function, but rather just as a documentation or as a note. So the hashtag pound is used to comment out specific things. If another use of the pound sign to comment things out is, say for example, you have typed in a function or an argument and you don't want to run it, you can type in the pound key, the pound sign, and R will not read it as a command to be run. Okay, so that's one thing. So I usually, just for my use, I typed in the task number, the exercise number, and all the other informations. I indicate the date of when it is done or when it's supposed to be submitted. I can even write my name here, comment out and type in my course, ADRS, uh, program, or whatever documentation that you want to remind yourself. I find this very helpful because I can always go back to these comments and remind me of why I am running a particular command. So if we start from the scratch, what I usually do after labeling my script is to set the working directory, as I already mentioned earlier. So I'll run this code, set wd parentheses, and inside that's the file path. In MacBook, running a particular function or command entails pressing in the command and return button. So I'm pressing command and return, and it will uh, show that here in the console that that particular argument has been run. So it shows here that my working directory has been set to the specific folder that I want to. Another thing that I'd like to do, or that I need to do, is to run or open or call the libraries that I'll be needing. So I'll comment some of the libraries that I won't need in this analysis. I won't need readexcel, I won't need Haven, and I won't need Reader. So all those other libraries here, I'll be needing them. So, but before running the libraries, in another as a preparation, you should install the 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 packages first. Here we're starting with the library because I've already installed it earlier. So the libraries that I'll be using is tidyverse, which is a nice collection of functions and commands. I'll be also using the modern dive library. Modern dive is really interesting for me because it actually has a website, a modern dive website, which uh, provides a really good introduction on how to make use of R and the tidyverse package when doing um, regression. So it runs you through data visualization, data wrangling, which is manipulating your data, importing and tidying your data. So if you're interested to learn more specifically on these things, you can go to moderndive.com. And this is actually a free website, but they also have a book which introduces you to more in more detail about these things. So I'm going to use that library. I'm also going to use the skimmer library, which helps us summarizes us in making summaries of the data. I'll use ggplot too, which I love a lot because this is something to do with data visualizations. And just to share, my interest in R really started when I realized that I can make beautiful and colorful figures and tables in R. So this was the buy-in for me, that I have to learn this because I can make really, really beautiful graphs and figures using this. So we will be using that. And I'm going to use the foreign package because I'll be using the SPSS dataset, the dataset in SPSS format from uh, Keith's book. Now, the third step that I'll do, that I want to do when importing and preparing the data set, is to import the data set that I'm using. So earlier I showed you the point and click of process by using the environment tab, import dataset, and then the succeeding steps. But if you're going to use the syntax to read in the data set, I can use uh, the read CSV file if I'm going to make use of the CSV document or the foreign library. So before we get to that, I need to first open the libraries. So I'll highlight these ones, and R will only run all those libraries which are not commented out. So if I highlight this one and click command return, so as you can see here below, this means that, and it did not give any error. So this means that it's already, that it has called in the libraries that I need. Okay. Another The next step would be, as soon as I run the library, is to read in the data set. So as I mentioned earlier, I'm going to use the foreign function, the foreign package, and the read.spss function to call in the data. So I can do it in two ways. One is I can just run read as .spss function, identify the path name of my uh, SPSS file, which is .sav, and it will, if I click on this one, it will read it. It will read the file that I have, and it will be shown in the console. But that is not what I want. What I want is that to have a data set that I can work on. And that is where creating an object comes in. So I don't want R to just read the SPSS file, but I want it to read and create an object that is workable for me. So creating an object, like what I mentioned in R, like what I mentioned in the previous video, entails identifying or denoting uh, any data frame or any values or array of data onto a particular creating an object, like denoting a particular data frame using a certain label. So in this case, I would want to call, or I would want to create an object called NELS. NEL stands for the National Education Longitudinal Survey, which is actually the data set that I'm working now. So I want to call my object NELS, and I want to assign my data set. I want to assign it to this particular label. I want to create the label NELS with create an object NELS, which is basically the data set that I'm going to work in. So I'm going to use the assignment operator. So this uh, code here is what we call the assignment operator, which basically assigns this data set to that particular data frame. So I'll be using that to create the data frame that I want to work in. So NELS would mean uh, this one. There are other commands here. Basically, what this is telling is that I want to read that SPSS. I want R to read the SAV file. I want it to be a data frame. That's why to data frame is equal to true. And I don't want to use the value labels that are originally found in the SPSS file. So that's basically the what the command means. So if I highlight this and command return, it will do exactly that process. Then I will use the view function. So I want to view the NELS data frame. So the view function, I think, is from the utilities, our utilities package. Uh, and this is a very common function that you will be using later on. So if I do that, view NELS, I highlight it, or probably just hover my cursor at the start and command uh, and return, then I will be given this data frame that you are seeing now. And the data frame is called nels. And you know that this function work because if I look at the environment, you can see here that I have now an object which is nels, which is a data frame, and with 1,000 values, with the value of 1,000 observations of more than 1,000 variables. So this only shows that the data set has been assigned to the object nels. Okay. And I'll be using nels. I can use now the label nels to work out my analyses. So in this particular example, I am not happy just working on nels because as you can see, nels is comprised of 100 observations with more than 1,000 variables. But what if I only need a few of the variables? I only want to work on, say, 1, 2, 3, 4, 5 of the variables in that large data frame. So I can obviously make use of nels to do that, and uh, it will be fine as well. But in my experience thus far, I like to limit the variables that I'm putting in or that I'm working in, and only those that I need and want to be showing in the data frame. So what I'm doing next here is I'm creating another object which I call chap4 for chapter 4, and these object will only have the 5 variables of interest that I'm want to work with. So to do that, I'll create chap4 and use the assignment operator. So then I'll use nels because nels is my original data frame. So I'm telling R that first I want you to create chapter 4, and you will do that by first calling in nels data frame, meaning opening it or uh, calling it in, and then I want you to do the remaining functions. Now here I want to introduce us to the pipe operator. So this percent greater than percent code here is what we call the pipe operator. And there's actually a lot of discussion about how it came to be, but in simpler terms, the way I understand it and the way that makes sense to me is that it pipes in the process, or it tells the R that after doing this, then you have to do this second process. So it's like a then command that you can use to tell R to do a series or a sequence of processes. So for this one, I'm telling R to create chap4 as an object, and it has to do that by calling in nels, which is my original data set. And then I want R to select 1, 2, 3, 4, 5 variables from nels. And I will do that using the select function. Now you can see here that I'm using dplyr : select. So what this does is, this is just actually to remind me that the select function is coming from the dplyr package, which actually is a package that is called in every time you call tidyverse. Now, I can, of course, since I already uh, opened the libraries at the start, I don't need to type in dplyr here. But remember that in the previous video, I mentioned that sometimes the function the function name is used by different packages, and they would have different uh, outcomes when you use that. So what this is doing is that I'm telling R that I want it to use the select function specifically from the dplyr package. So it's going to resolve the potential conflict when there are two or more packages using the function select. Okay. So going back to the process, I want R to select these 5 variables, and basically it's just looking at the variable names that you have in your original data set. So I want to use FFU grad, bipared, F1S36A, um, F1S36A2, and bytests. So what are these? I don't know what these are when I look at when I just look at the select. But when I look at my code book, which is a good practice to have, uh, each of these variable labels have its name. It pertains to a particular variable that you are wanting to explore. So I want to make more sense of these variable labels, which are which might not be meaningful as it is now. I want to rename them so that can I can make it more understandable for me and for the other people that I'm working with. So I'll use another pipe operator to tell the R. So after selecting these 5 variables, I want R to do this next. And the next thing that I want R to do is to use the rename function from dplyr to rename the variables that I just called in. So the names that I want R to use is for FFU grad, I want it to be named as grade. For bipared, I want this to be named as pared, which is parent education. For F1S36A1, I want R to be naming it H work in, which is homework done in school. I want F1S36A2 to be labeled as H workout, which is homework done out of school. And I want by test to be labeled ACH8, which is achievement scores when the participant was in 8th grade. So by using this rename function, the variables will make more sense to me. Now, if you're doing this analysis, probably you may want to use another name which makes more sense to you, and that is totally fine. So I can name FFU I can name, for example, bipared as parent education, and it will be fine. So it depends on what makes sense to you. But for me, pared is fine. I already understand what it means. But aside from that, I don't want R to just select the variables that I'm interested in and rename it this way. I also want R to omit the missing values from this particular data frame that I am creating. And by using the na.omit function, what R will do is it will uh, perform a list-wise deletion. So all of the observations with at least one NA, it will exclude from the data frame. Now, the dealing with missing values is is in itself a complicated discussion. And there are a lot of ways to deal with missing values, as probably we will be discussing later on. But at least for this analysis that I'm doing now, I want R to delete, to omit the all observations with at least one missing values. Okay. And I'll do that using the na.omit function. Okay. So as you can see here, I have a series of commands that I want R to do to create chapter 4. Again, I want R to call in Nell's dataset and then select the variables that I'm interested in, and then rename the variables using these meaningful variable labels that I wanted. And finally, I want R to omit all the missing values or all the observation with missing values in the new data frame that I'm creating using list-wise deletion. Okay. So I can actually do all these specific steps one at a time, which is fine. But since I have the pipe operator, I can do it in this particular sequence. So I'll highlight and run this one using command and return, right? And as you will see here in the environment, a new object is created named chapter 4. It has 879 observations, which means that certain observations were deleted. And supposedly, the number of variables is 5. So it means that we have created a new object called chapter 4 with 879 observations because all of the observations with missing values were deleted already, and I'm only working on with 5 variables. Now, I have just created the chapter 4 object, but if I want to view it, again, I'll be using the view command. So if I type in, say for instance, if I type on view, open parenthesis, then I type in the new data frame, chapter 4, close parenthesis, and then run it, the chapter 4 data frame will appear in my source panel. So as you can see here, I only have 5 columns for the grade, PARED, age working, age workout, and ACH8. And this particular data frame has 879 uh, observations supposedly, because it already deleted. Uh, it has 879 entries because it already deleted those entries that have missing values, right? So that's one way of preparing the data that we want to work with. And uh, in my experience at the start of using this was a grueling experience, just importing the data set, calling in the library, and creating a data frame which is comprised by the variables that I'm interested in, renaming it, and managing the missing values. All of these by themselves are challenging. But uh, if you as soon as you get hold of the basic and fundamental steps, it will be a little easy for you. So I think we'll end at that point in this particular video, and I'll probably give you time to work on the same processes that I shared earlier. And on the next video, we will continue the process of actually making the descriptives and the box plots.